So friends, we have already studied the first and second laws of motion. Let's move on to Newton's third law of motion. Before actually finding out what the third law is, assume that you are leaning against a wall and pushing the wall. Will the wall move? No, the wall will not move. What is actually happening? Even though you are applying a force on the wall, it is still not moving. What happens is that even when you are applying a force on the wall, there is a force that the wall is applying on you as well. In simple words, let's call the force your hand is applying on the wall as force A, and the force that the wall is applying back on you as force B. So, force A is the action force, as you are trying to perform an action on the wall. In reaction to force A, the wall is applying a force back on you, that is called reaction force, force B. In short, action force is the force that your hand is applying on the wall, and reaction force is the force that the wall is applying back on your hand. It is important to mention and remember that action and reaction are always opposite to one another. Like you are applying a force on the wall, but the wall is not moving because it's also applying a force back on you. The amount of force your hand is applying on the wall is equal to the amount of force that the wall is applying back on your hand. So, as I said, action and reaction are opposite to each other, and at the same time, they are also equal. This example defines Newton's third law of motion, which says, to every action, there is always an equal but opposite reaction. As we discussed in the example, that the force your hand applied on the wall, corresponding to that force, the wall also applied a force back on you. This force is opposite to the force you applied on the wall, but is equal to the applied force. For instance, if your hand was applying 20 newtons on the wall, then the wall will apply 20 newtons force back on your hand. Using this concept, why does the wall not move? Can you think of a reason? Well, that is because the forces are balanced and net force in this case becomes 0. Here is a man applying a force.